This next demonstration never ceases to amaze me, no matter how many times I do it. I've got the Van de Graaff generator. It's going to generate its large positive charge on its dome, and that's going to create an electric field in this room. And what that means is charges at various distances from the dome are going to have different amounts of energy. And what's cool about that is a device like this simple fluorescent light bulb, much like the big ones we often see in the lighting in schools, or maybe you have one of these in your kitchen or your garage. This works by having a difference in energy across the ends of it. So believe it or not, I can actually light this just by holding it near the Van de Graaff. I'm going to do that. I'm also going to turn it 90 degrees, and we'll see if there's any difference. I'm then going to repeat the experiment with another type of bulb, which is called a gas discharge tube. Sometimes these are called neon lights, although this one has helium in it, not neon. And these also work by having a large difference in energy for a charge on either end of it. So we'll explain this a little bit afterwards, but I'm going to light both of these different types of light bulbs just by holding them near the Van de Graaff. That the Van de Graaff can light a fluorescent tube it's not touching is a strange thing. And to understand it, I want to use the analogy we've used already, which is that the electric field around the Van de Graaff can sort of be understood by understanding the gravitational field around Earth. The Van de Graaff alters the space around it and causes charges to feel forces. Earth alters the space around it and causes masses to feel forces, namely gravity. So if there was a person where I've drawn this guy, far from the Earth like that, clearly gravity is going to pull him back down. To get him there, work has been done. It's not clear what that work was. Maybe he had a jetpack. Maybe he fell out of an airplane. Something pulled him away from the surface of the Earth and put him where he doesn't belong. It gave him more potential energy. So, given the opportunity, he will release that energy and move back to a more normal location for himself. In other words, the potential energy that was given to him will be lost, probably as kinetic energy, and he'll move back closer to the surface of the Earth. If that all makes sense, then you should understand what's going on with the fluorescent tube. If there's electrons towards the left end of this tube, if there's negative charge, and there are because it's made up of atoms, they are farther away from the positive Van de Graaff dome. That means each of those electrons has a higher potential energy than it would if it was on the right side of the tube, because electrons want to be closer to the positive. So if there's some way that charge can move closer to the Van de Graaff, it will. And that means there's a potential energy difference between the ends of the tube. Well, the potential energy difference per charge, per coulomb, is called the voltage. And that means we have a voltage difference from one end of the tube to the other. And that's what makes a tube light. That's what makes current flow through a tube. It doesn't happen when the tube is straight up and down, because in that case, the ends are equidistant from the Van de Graaff, so they have the same potential energy per charge, and there's nothing to make the charges, quote, fall from one end to the other. So if you understand why this person in this location tends to fall towards the Earth, you should understand why current runs through the tube and lights the tube. So put that down gently. Turn on the Van de Graaff. We'll go turn the lights out. Alright, so I'm going to come in and hold the tube from the side. We'll see if we can get it to light up. So there you go. It is indeed lighted. I'm not touching the dome at all. It stays lit until I get it close to being in the vertical position. If I tilt it back, it lights up again. Here's one other fun thing I've noticed. I'm standing next to a metal chair, and watch what happens when I touch my foot to it. I bet you can hear that lightning bolt. That means there's charge passing through me to ground. And that's making the bulb get brighter, as long as I do that. Kind of hurts though, so I'm going to stop. I'm going to repeat it now with the helium tube. It's kind of the same deal. If it's horizontal, I get the pink light. If I turn it vertical, I lose it.